Alright, in this last video in 13.1, we're going to look at problem 10. It says, suppose the balance b in a savings account after t months is given by the function b of t equals $1,500 times 5/4 raised to the t power. Part A says, what's the percentage increase in the balance month to month? Okay, so our multiplier here is 5/4. And if I break this down as 1 plus a quarter, that's the same thing as saying 1 plus 0.25. So I'm taking 100% of the original amount and then I'm tacking on 25% extra. So I'm applying a 25% increase here. Okay, and our multiplier is just 1.25 from month to month. Okay. So then for part B it says, what's the net percent change in the balance after 1 year? Is your answer equal to 12 times your answer to part A? Explain. Well, let's first find the balance after 1 year. So the balance at year 1 would be what? Well, since t is measured in months, I'd want b of 12. That's going to be 1,500 times 5/4 to the 12th. And if I round just to the nearest cent, I get $21,827.87. Okay. So then to find the net percent change after 1 year, well, let's first just figure out how much did the money grow here. It went from 1,500 to $21,827.87. So I can measure the change there as my 21,827.87 minus the initial amount, which is my 1,500. And now I want to divide that by, if I'm wanting to find percentage change, I'm going to compare that difference to my original amount, which is $1,500. And when I compute that out, you wind up getting 13.552 blah blah blah, roughly this. Okay. So what is this though as a percentage? Keep in mind this is a decimal value. It's 13.552. So as a percentage, I move the decimal 2 spots to the right. This would actually be a whopping 1,355.2% change. Okay, that is our answer there. And then is this answer that we just got 12 times the answer to part A? Well, what is 12 times the answer to part A? We said month to month we're increasing our balance by 25%. So if I did 12 times 25%, well, that's going to give me 300%. But we know from from this previous calculation here that the true net percent change is in fact 1,355.2%. So the answer there is no. And so why is it not as simple as just taking the 25% that I'm getting each month and multiplying it by the number of months, which in this case is 12? The problem with that reasoning is that as you go from month to month, right, we're not adding, we're multiplying. And the thing we're taking the 25% increase of is itself growing. So there's this multiplicative effect, also known as a compounding effect, that's going on here. So simply taking that percent change and just basically multiplying it by 12 or equivalently adding it to itself 12 times, right, is going to give me a significantly lower percentage there than the actual true percentage. Okay, and this principle here, I mean, these are kind of dramatic numbers, but true compound interest, like in a savings account, works in exactly this way. And so your actual percentage increase, what would be called the annual percent yield, is actually going to be slightly larger than the rate that's quoted. Okay. Well, that's going to do it for this problem and this section. So I'll see you next in 13.2. All right.